Okay, so this will be the second day on section 1.5 on, and this one is actually solving inequalities. The other day we did the solving equations with an error of 0.01. This is solving inequalities with an error of plus or minus 0.01, and solving absolute value inequalities. Okay, so let's look at the top part first, solving inequalities with an error. And we're going to do these graphically. I want to go through an example in your book. It's on page 59. Okay, you can open up your book to that if you want to. And it's example 5. They ask you to solve 2x cubed minus x squared minus 14x minus 12 is greater than or equal to 0 with an error of plus or minus 0.01. Okay, so what you need to do on your calculator, go ahead and put in that in y sub 1, put in the 2x cubed minus x squared minus 14x minus 12. Okay, and then you need to, if it's with an error of 0.01, graphically, we're doing those graphically, and change your scale. Okay, let's look at the window. Go zoom standard, zoom 6, and I really don't care on the graph what it looks like, and change the x scale to 0.01. Okay, so you're really on zoom standard, and that zoom standard is the x goes from negative 10 to 10, and this is the critical part. Make that error 0.01. The y is negative 10 to 10, and that scale is 1. So that makes for a wide axis, okay, and graph it. Okay, you're not seeing the complete graph. Okay, you're not seeing the minimum, but it comes something like this. And here's part of the what they would call the hidden behavior. Okay, you can't tell, is that crossing or touching or not touching. Okay, so right now we can't tell. Okay, so what I need you to do is to do zoom in, and you have to get your cursor. We're going to have to get your cursor over here close to, should blink a little bit. Okay, get it close to that point. What's that? Do zoom in. Okay, and then you're just going to press enter. Okay, and already you can see it's crossing it. Okay, because you get a little bit above the line. Okay, and just get your cursor close. I'm going to do the one on the far left first. Okay, get your cursor close to that point. Press enter, because you're still in the zoom in mode. That's the nice part about that. Now you definitely see it crossing. Okay, get your cursor close to that point. Press enter. You keep doing that until it crosses between two distinct tick marks that you can read. Okay, get your cursor close to that point. So we actually have to do this zoom in process 3 times because it's crossing 3 times. Okay. Press enter. Looks like it's going right at it, doesn't it? Okay. And go 3 decimal places. If you round that, it would actually round up. So it is crossing. So you may have to redo your graph a little bit. It is crossing. It goes, crosses, comes down, comes back up. Okay, so this one and we're going to round it to a negative 1.500. Remember, you got to go 3 decimal places. Okay? That's okay, what that means is it's like negative 3 times 10 to the negative 10 power. This is the exponent, so that's like the 0. That's like 0. Okay, on your calculator. Anytime it switch over to that scientific mode, let's read it like 0. Yeah, because that's like negative 3, and then sorry, it would be like a negative point. Then you'd have all these zeros, 9 of them, and 3. Right? So there, that is reading that as 0. Yeah. Okay. Now you got to find this one. Okay. Okay. Now, one thing we could have done. Okay, go back to Zoom. We got to go back and start Zoom 6. Zoom 6. We got to change the window back, the X scale. You got to go back to that 0.01. Okay, and you should get something like this. Now, if I know I'm going to do this 3 times, okay, and I don't want to have to do that, put the window in 3 times, okay, go Zoom. Right arrow over to memory. Okay, Zoom store. That's going to store that graph and that window in the memory. Okay, so I don't have to recreate it. Okay, now let's go do Zoom in. Okay, and you got to get your cursor close to this side of where it crosses. Press enter. Okay. Keep doing that. Sometimes you might have to do it about 6 or 7 times before you actually see it cross between 2 tick marks. And then you can round it to 3 decimal places. Okay. It's just another method to figure, okay, your solution. Okay. And it looks like 1.23. Let's go one more. Let's go one more. So I would have 1.236 negative. So you zoom in several times. Might want to put that on there too. You're zooming in. And we did zoom right arrow over to memory. And Zoom store. Okay. Okay, so now you got that answer. Now let's do Zoom. Now recall your picture. Right arrow over to memory. And do Zoom recall. RCL. And you didn't have to put in that window again. It brings that graph back. Okay. Okay, and then if you did this one over here, we're not going to do this one. This one is 3.236. Okay. Now you have to go through all that, but that's not your answer. Okay. Your answer is where is this graph greater than or equal to? Where is this graph above 0? You can just think of this, if I graph this in my y sub 1, and if I graph this in y sub 2, y equals 0 is this line. So you have to say, where is this graph above the x-axis? It's above the x-axis from here to here, and it's above the x-axis from here to infinity, because it just keeps going. Okay? So you go left to right across the screen. And I would probably highlight it or circle it, this, and then we have to write out the answer. This is where it's above. If it would be less than or equal to, it would be from, well, let's get this answer first. On this one, and it's equal to. Okay, this is determining, the equal sign determines that you're using a bracket. Okay, so the bracket, and you go left to right. So it's bracket negative 1.500 to a negative 1.236. You have to go left to right, okay? And then union that, okay? Anytime there's more than one part to it, you're always going to have the union symbol, okay? And then union that with bracket 3.236 to positive infinity, and the infinities are always a parentheses. And that infinity is not going up, it's going x values out to the right. Okay? Make sense? If I change this symbol and made it less than 0, okay? If I made that equation to be less than 0, then I would say, where's it below the x-axis? Then it would be from a negative infinity to negative 1.500, okay? And less than would be parentheses. And then its union, it's also below the x-axis from negative 1.236 to 3.236. Okay, if it was a less than, less than symbol. Okay, that makes sense? So you're really saying, where is that graph above the x-axis? On this one, you're saying, where is it below the x-axis? And the greater than or equal to, equal makes it a bracket. Okay? So you're not solving those algebraically. You're solving those on the calculator. And you have to make sure, if they say with an error of 0.01, you've got to put that in on your x scale. Okay? Okay. Let's go to the next part I want to go through as another example, and it's on solving absolute value inequalities. Okay, so draw a little separator. We've solved absolute values in Algebra 1. Probably not much in geometry. Probably did a little bit in Algebra 2. Okay, but probably did not do much with the inequalities. Okay, and this is Advantage Calculator. Okay, we're going to look at page 63, example 11. Okay, and people, I'm serious about taking time to read this book. You have got to get used to reading. You will be amazed when you go off the first month of college how much reading. Instead of saying read a section, it's read 3 chapters for the next time we meet. Okay, the reading is, and you better make sure you have your eyes checked before you go. Okay, there's a lot of reading. Okay, this is example 11. Okay, they will ask you to solve the absolute value of 3 divided by x minus 2. The absolute value of that, okay, is less than 1. And they want you to do it algebraically, and then support it graphically. Check it on your calculator and draw the sketch on your paper. Yeah. Basically, they're just saying you should be able to check your answer, but put it on the... Part of the reason I want you to show it is because you don't get to take this book with you. Okay? So you can at least say, oh, yeah, okay, that's what the graph should look like. Okay, one thing, when you have an absolute value together, okay, like this, a fraction in the absolute value, it is legal to split it up. Okay? The absolute value of 3 over the absolute value of x minus 2. And absolute value of 3 is just 3. So you're down to this. And 1, because this is like 1 fraction equal to, I can make this a fraction, okay, and then cross multiply. But when you cross multiply on an absolute value, whatever's on the upper left is going to stay on the left. Okay? Okay, so if I had, if I cross multiplied this, 3 times 1 is just 3. Okay? And is less than, and if I cross multiplied here, the absolute value of x minus 2. Now you do have to be careful if you multiply by a negative. If you multiply by a negative, you have to reverse the arrow. Okay? Okay. Everybody okay so far? Okay, and I'm actually going to rewrite this so that it's on the left side because it looks like this in your notes. Absolute value of x minus 2, and it's greater than 3. Okay? If it is, now you have to go back and kind of remember on this symbol for absolute values. If it is an absolute value and it's greater than or equal to, it is an OR statement. Okay, and the final graph is a union. If it's an absolute value symbol and it's equal sign, okay, an equal sign is an OR statement, and the final graph is a union. If it's an absolute value and it's a less than or equal to, it's an AND statement. Okay, and the final graph is an intersection. This goes back to your Alg 1, Alg 2. That's just kind of refresher. Okay, so this is a greater than, so it's an OR statement. Authors do this different ways. Some authors take what's inside the absolute value, keep that the same, okay, and reverse the sign on the 3. Some authors take and consider both cases, take what's inside the absolute value and consider the positive or negative. I think your author keeps it the same and does the change on the sign of the 3. So we would have two cases. Take what's inside the absolute value, you get rid of the absolute value symbol, okay, and you do greater than 3. Since it's an OR statement or greater than statement, it's an OR statement. You still have x minus 2, and now you reverse that symbol, make it less than, and then you also change that to a negative 3. When you do absolute values, you will always have two cases. It will always go from the absolute value to two parts. Okay? Always. I think your Algebra 2 book did it this way too, right? Okay? Didn't they leave this part the same, x minus 2, and change the sign of the number? Isn't that right? Yeah. The old Hoot Mifflin books way back did it just the opposite. Okay? Okay, so on this one we would add 2. So x would be greater than 5. Or add 2. And you solve these same, if you have to multiply or divide by a negative, you reverse the arrow. Okay, and this one, x is less than negative 1. Okay? Now, in your book, the author's not going to write it like that. The author would write it, well, let's do it graphically and then you'll be able to see. Okay, so do the graph. Okay, if we go up, there are two ways to graph this. Okay, one way to graph it is to graph this in y sub 1. Okay, so let's graph the absolute value. So you have to go to the math key, right arrow over to number, absolute value of 3 divided by, and then you need to put, the author's not going to tell you, you really have to concentrate on parentheses. Okay, parentheses x minus 2, because if you don't put in those parentheses, you're just dividing by the x. And then close the parentheses, close the parentheses. Okay? Okay, and let's just do zoom 6 to get that graph. Okay? And then you can graph this in y sub 2. Graph. Okay? I'm going to change this. Let's go zoom. Let's see if I go to zoom decimal if I see it. Might not get it all. Nope, I have to go over a little bit. Let's go change our x max to maybe 6. Okay. So if we did this graphically by that method, okay, our picture would look like this. Put arrows on both ends because it does continue. Okay, and then if I graph in y sub, oh, we got to go a little bit lower. Y sub 2 if I do, okay, now find those points of intersection. So you can do second function calculate intersect. Get it close to that point of intersection. It says first curve, just press enter, and I'm on the absolute value curve. Now I'm on the y equals 1. Yes, just press enter. Okay, and you should get the -1. Okay, so this x value is -1. And if you check this x value, would be the +5 out here if you did second function calculate. Okay, intersect. Okay, so what you're really saying is, where is this absolute value less than 1? Where is this graph below this line? Go left to right. It's below the line from -infinity to -1. It's below the line from 5 to +infinity. So that should match up with this. If I look at this one first, from -infinity to -1, and it's less than, so that's a parentheses. It's an or statement, so that's a union. Okay, and then go from 5 to +infinity. It has to go, like, you can't write from +infinity to 5. It has to go left to right. Okay, now that's one way to graph that. The author may not graph it that way. The author may do this, and the final answer is actually this part down here. Where is it below the x, or that line y equals 1? Instead of graphing this in y sub 1 and this in y sub 2, the author is probably going to subtract 1. Okay, so the author is probably going to do 3 divided by x minus 2, absolute value of that, subtract 1 is less than 0. So then you'd really be saying, where's it below the x-axis? Okay, so let's go back and graph it that way. Okay, just take out the y sub 2, clear that one out. Go back up here and subtract 1. Okay, it will change the looks of your graph, but your answer is still the same. Okay, if I graphed it that way, now it's going to look like this. Okay, it will change the graph to look so. Now you're not saying where does it cross the line y equals 1, you're saying where is it below the x-axis. Okay, but it's still below the x-axis from -infinity to -1. Okay, still below the x-axis from negative infinity to -1. Union that with 5 to +infinity. So you get the same answer. The graph just looks a little bit different. Those two, and instead of doing second function calculate intersect, you would do second function calculate 0. Right? You get it to the left of where it crosses. So you have to get it down below. As long as that y value is negative, you're okay. Press enter. Puts a little triangle on there. Okay, get it above where it crosses. As long as that y value is positive, press enter. Yes, just press enter. And you still get the x value -1. So on this one, up here you're doing second function calculate intersect. And on this one you're doing second function calculate. Does it say 0 on the new calculators? Okay. Okay? Everybody okay with that? If, I did one thing wrong on this graph. What did I do wrong? These are less than, greater than symbols. Change your graph. That should be open. This should be open. Erase it. Make it open. That's my fault. And it's not actually this part is not part of the graph. They are going to ask you to circle the graph or highlight the graph. So you have to look at so it's this part down here. Okay.
circle it, highlight it. It would not be the top part of the graph. Okay, those should be open circles. Okay, these should be open circles. Okay, there should be an open circle here and an open circle here. Correct that. Okay, that's critical on the graph. You know, I'll count that wrong. Okay, good enough. A couple of examples to get you started. Okay. Okay, assignments on the iTunes U. That should get you started.